Hello everyone, this is Team Athena. We have made a project on sales management data analysis using Python. To run this project, we need to import a few relevant libraries and upload the dataset. We have done this in the first two cells. After this, we need to read our data and store it in data variable. Now we'll perform a few basic functions on our dataset. First, we have used head function, which by default will display first 5 rows of the dataset. Next, we have used info function, which will fetch us a concise summary of the data frame. It will tell us how many non-null values are present and what is the data type of the columns in the dataset. Then we have used describe function to show some statistical data like count, mean, standard deviation, minimum value, maximum value, and percentiles of the numerical values of the series. Now as you can see, data.shape will give us the shape of the dataset, that is, the number of rows and columns present. Data.columns will display all the column names. Data.duplicated.sum will check if any duplicate rows are present in the dataset. In our case, no such row exists. Here, data.isNull.sum will print the sum of missing values in each column. And data.nUnique will print the number of unique values in each column. This is our inference from the above information. Here we are printing those rows of columns sales price, discount amount, and item number which are containing null values. We can observe that the row at 3, 4, 8, 8, 9 position is having null values for all these 3 columns. Therefore, we are printing all the column values for this row. We can see that the item is Monarch Manicotti. Therefore, we'll print those rows containing this item. We found that at these 2 locations, we are having this item, hence print the column of values for the same. We observed that for both these locations, we got item class as P01 and item number as 29268 that we have mentioned over here. Here we are showing the number of missing values and their percentage. Now we observe that unnamed columns do not have any values at all. Therefore, we can remove these 2 columns entirely. That we have done over here, we are dropping the columns named as unnamed and then displaying the data. Next, we have observed that we can't draw any inference from item class and item number columns. Hence, they are useless and can be dropped. Now we are printing the data over here.
We have found out the null values, their percentages in respective columns, and dropped a few of them since they were not useful. We can now move on to replace the null values in columns with percentage less than 10. We start by dropping the rows with values less than 0 as these do not possess any meaningful information in the dataset. This action will not bring about any major change in the trends as we have a significant number of rows left. We start with discount amount. We use the function fillAny and mean to replace the null values with the mean of the column. We perform a similar action for sales amount as well as for sales price. We do a final check to find any more missing values and notice that there are none left. We print our dataset one more time to see all the above operations we have performed. Moving on to the sales trends, we start by sorting the date key column. We use the function sort values and observe that the date key column has been sorted. Also, that the date key column ranges from 1st January 2017 till 31st December 2019. We then move on to find the unique month, unique year, and unique month year from the date key column. We create 3 new columns, month, year, and month year, which we will be using later on. We use the function strftime from the pandas library, which returns year, month, or date to perform these operations. The unique months observed are January, February till December. The unique years observed are 2017, 2018, and 2019, and the unique month year are listed below. We move on to find the month-wise sales trend. We first group the data by month, a column which we created previously, and plot a line plot against sales amount. We noticed that during the years 2017 till 2019, the highest sales amount was obtained during the month of March and the lowest during the month of May. For year-wise sales trend, we plot a bar graph between the years and the sales amount to find the highest sales amount. Here we see that the highest sales amount is obtained during the year 2017 and the lowest during the year 2018. For month year-wise sales trend, we plot a line plot ranging from January 2017 to December 2019. This was plotted against sales amount. From this plot we infer that the maximum sales amount obtained was during September 2017 and the lowest during January 2019.
Now we wish to observe the data for a specific year, say 2017. So first we use the setIndex function to set the index of the data according to the dates present in the date key column. And then we use the nUnique function to find the number of unique occurrences for each column for the year 2017. Next, we have plotted a graph for sales amount in different months for the year 2017. It starts from Jan 2017 and ends at Jan 2018. Next, we want to find the sales amount and quantity for a specific date, say 31st December 2019. So we have created a new data set showing only the relevant columns for this particular date. And then we have sorted that data set according to the names of the items using sort_values function. Then we have plotted a graph of items versus sales quantity and sales amount for this particular date. There are two parameters on the y-axis. And from this graph, we can conclude that Discover Manicotti has the highest sales amount, whereas the item Walrus Chardonnay was the most sold item on 31st December 2019. Next, we have plotted a distribution of items based on the units of measure. There are three units of measure: EA, which stands for each, SE, which stands for SI unit, and PR, which stands for pair. So we have plotted a pie chart for the same. And from this pie chart, we can understand that most of the items were sold individually. 8.7% were sold in SI units and only 1% were sold in pairs. Next, let's see some trends based on sales amount. So first, we have created a data set based on top 1000 values of sales amount using the nlargest function. In the original data set, a single item has different sales amounts. Hence, the total number of items in this data set will be less than 1000. First, we have plotted a graph of items versus sales price. And from this graph, we can understand that high top dried mushrooms are the cheapest, whereas Imagine grape popsicles are the costliest. Next, we have plotted a graph of items versus sales amount for the same data set. And from this graph, we can understand that high top dried mushrooms have generated the highest sales amount. Next, we have created a data set of top 1000 values of sales quantity and plotted a graph of items versus sales quantity for the same data set. From this graph, we can see that high top dried mushrooms were sold the most. So summarizing all the three graphs, we can come to the conclusion that even though high top dried mushrooms were the cheapest, they were sold the most and hence they generated the highest sales amount. Next, we have plotted a graph showing the sales amount generated by each sales representative using a strip plot. From this strip plot, we understand that the sales representative number 149 is responsible for generating the highest sales amount. And lastly, we wish to find the relation between sales price and sales quantity for top 100 values of sales amount. So we have created a data set for the same, and we have used a rel plot to get this distribution. So we can see that only 8 items are responsible for top 100 values of sales amount. And from this rel plot, we understand that high top dried mushrooms are the cheapest, yet they were sold the most, hence generating the highest sales amount. Thank you.